Hey class, welcome in for another space science lesson. This is our lesson on gravity. This will be part one of a couple lessons on the force of gravity. Call this one Gravity Rides Everything because it's so important and something we don't really think about a lot, but it affects us all. We are all currently around and um, basically beating gravity, at least temporarily, just by standing up or sitting down. All right, so let's begin. Gravity. Before we begin today, you're going to answer this question, actually two questions, in the document I shared with you. What do you already know about gravity? What is it, and where does it come from? So you're going to go ahead and pause and answer that, and no looking things up because that's not the point of this. Obviously, you're going to find out about gravity in a little bit, but tell me what you already know or what you already think you know. So where does this magical force called gravity come from? You've probably experienced it. You've probably learned a little bit about it. So answer that first question now. So go ahead and pause now. Okay? Hopefully you've paused and answered that question. If you haven't yet, make sure you do. Well, you may have experienced gravity in something like this. You may have fallen, taken a face plant, wrecked something. Why do we fall down? If we trip, we go straight down? Well, that's that powerful force of gravity. It's always pulling on us, and it can cause accidents like this, hilarious things to happen, or maybe something like this has happened to you. You spilt your ice cream, right? That's like the classic terrible thing to happen when you're young or old. I would be pretty bummed out if I spilt my ice cream, but kids dropping their ice cream cone or tripping over something and falling over and everything goes splat. Well, why is it doing that? Because gravity. And so you might go, oh man, sometimes I wish we didn't have gravity. Well, you'd be in a lot of trouble if we didn't. But this is some of our classic interactions with gravity. And you are up against gravity every day. Um, you know, the time that we're not really against it, and we still are, is when we're lying down. But that's so we are up against gravity at the least. You probably experienced gravity in maybe some of these ways. Maybe you've gone sledding and fallen over like that. Uh, and the reason you are sliding is not only because of the less friction of the snow in the sled, but you're being pulled down. You're going down with the force of gravity. Same with rolling down a grassy hill. That's why you're rolling, right? You don't have to put much energy in that. You just let gravity pull you down until you can no longer roll. So these are the ways we interact with gravity, and maybe hopefully ways that you have too. The classic and probably what comes to mind a lot in science is, or maybe you've heard of this guy, Sir Isaac Newton. The popular story, possibly a legend, maybe it was real, was that he was kind of thinking underneath the tree or taking a nap or whatever, and an apple fell and hit him on the head. And that's when he came up with the theory of gravity, that there must be some sort of force for why these things fall and go and try and find their way to the earth, right? They're always wanting to get to where the object is at rest. And so this is an important scientist, maybe you've heard his name before, way, way, way back when, who thought of this theory for gravity. So here's the definition, a very simple definition of gravity, but I'm going to have a lot more definition. Well, not definitions, but more explanations on gravity because it's more than just this. But when we're really simplifying, gravity is an invisible pulling force. It is pulling. It is pulling against you right now. So it's an invisible pulling force. So that is our simple definition, but we're going to have more to add to that. Right here, Earth's gravity pulls things to the center of Earth. It's always pulling to the center of the Earth because the Earth is the biggest thing around us. and the closest, biggest thing around us, right? We know the sun is much, much, much bigger than the Earth, but it's so far away that we don't feel its gravitational pull. Everything is overpowered by the Earth's gravity, and it's always pulling down to the center. So this is the classic science illustration. This ball falls down at my feet. We've got it looks like a lady in England or Ireland there. Which way will it fall? And we've got the boy in Central Africa, and this orange falls down to my feet. Looks like a tennis ball to me. We've got the boy in South Africa, looks like. So no matter where you are in the world, and right, the world is a sphere, it's going to fall straight down. So it's interesting to think you could be down here in Australia or Antarctica, and if you drop the ball, it's not going to float above you out into space and go out there. It's going to go straight down. So no matter where you are in the world, North America, Europe, Africa, Asia, South America, Antarctica, everything is going to pull straight down. Now, why is that? Why doesn't the ball just float down? Well, that's because gravity is pulling towards the center. And the Earth has a lot of mass. And the more mass you have, the more gravity you have. So you see the plane going there too. It's still pulled on gravity. So the more mass you have, the more gravity you have. And the cool thing is everything has gravity, all objects. We have gravity. There's a gravitational pull, but we can't feel that because the Earth's gravity is so strong. Can you beat gravity? Is it a strong force or a weak force? So you're going to answer this question in the document as well. I want you to, and if you need to pause, go ahead and pause and think of what ways can you beat gravity? I talked a little bit about that, but what ways can you beat gravity? All right. Hopefully you've thought of some ways you can beat gravity and whether it's a strong force or a weak force. Gravity as a force, it's kind of hard to talk about. It's kind of strong in some ways and weak in other ways. If you think about it, one way that we beat gravity, at least temporarily a lot, is jumping. When you jump up, you just beat gravity. We're not smushed to the ground. If we were in a place that had higher gravity, like a bigger planet that had more mass than the Earth, we could probably be smushed down. Maybe you've gone to the fair or carnival and got on the Gravitron swirly ride that makes it feeling like more intense gravity is pulling on you. But that's a different force, a centrifugal force. But we can jump. In fact, just standing or sitting or being up, you're beating gravity unless you're lying down. That's pretty much the lowest gravity you can be. You're temporarily beating gravity. Or maybe you thought about, well, I can get on a plane. That just beat gravity. Now, did it beat gravity forever? Well, just like jumping, you're going to go down at some point. The plane has to land or else it's going to run out of fuel. So you can beat gravity in a plane for a while, for a very long time, for hours and hours and hours, depending on the plane. But eventually they have to come down too. There's no human-made device that can beat gravity forever, right? Everything eventually falls. Gravity rides everything. Even the International Space Station, which is in low Earth orbit, they actually have to adjust it and use propulsion to push it back up a little bit because it slowly is being brought closer and closer to the Earth. And so they have to adjust that. And the further you are from the Earth, you're going to eventually be attracted to another gravitational object. And we'll talk about that in the next lesson a little bit more. So here are some important things. This will help you answer your questions as well. All objects have gravity that pulls on all other objects, even us. We just don't feel that because the Earth below us has such a strong gravitational pull. But if we were both in some part of space where there's nothing around, whoever is bigger is going to have a little bit more of a gravitational pull than the other. Objects with more mass have more gravity. So on Earth, you feel more gravity than on the moon because the moon's a lot smaller. The sun, which has much, much more mass, has more gravitational pull than the Earth. Jupiter, the largest planet, has a much larger gravitational pull than Earth. So the more mass, the more stuff, the more weight, the more big something is, the more gravity it has. And it is hard to leave Earth because of the pull of gravity, of Earth's gravity. It's extremely hard to leave planet Earth. We can temporarily beat gravity, but it's really hard to get all the way out of the Earth. In fact, well, that's why we've dedicated rocket science to it. Think about the amount of power that goes into especially a big rocket like this, the amount of fuel, the amount of force and thrust that it takes to escape the gravitational pull, to escape the Earth's atmosphere. It's extremely hard to do. So it's a strong force. So for tomorrow, so then there's this guy named Galileo, which talks a little bit. He wanted to know this thing about gravity, about how it affects the different weight of something. So he went up to the Leaning Tower of Pisa. I don't even know if it was leaning back then. And he had two cannonballs, a much larger and heavier one and a smaller one. And he dropped them at the same exact time to see which one would hit first. Now, I'm not going to tell you the results of that, but I want you to think and predict which one do you think would hit the ground first. And we're going to talk about this it's the weekend. We're going to talk about this on Monday's lesson about objects falling and their pull on gravity. So we had a very heavy cannonball and a small one. And you're going to do something similar. This is my challenge to you, basically your homework. You're going to need two pieces of paper. The paper need to be exactly the same size. So they have to be the same paper, same type of paper. So if you use like plain white computer paper, both of them should be the same size in the same paper. If you want to use lined paper, just make sure they're both lined paper. Just make sure that they're the same size in the same type of paper. And so one you're going to crumple up into a ball, and then one you're going to keep flat like this. So again, they have to be the same, one crumpled up and one kept just normal. And you're going to hold them at the same height, and you can get help from someone, a sibling or an adult, a parent. Try and keep them the same height and try and drop them at the same time. It's a little challenging to drop two things at the same time. So it might take a couple tries, and you should do this a couple times anyways, just to keep experimenting. And let me know what happens. Report your results. Tell me what happens. You have the crumpled up ball and you have the flat piece of paper, which are, in theory, the same mass, right? It's the same type of paper, same shape. It should be the same mass. So you're going to keep them even, drop them at the same time, and let me know your results. All right, guys, that's all I have for you today. Have a great weekend, and keep working hard, keep learning, and stay curious.